Okay, so in this problem we're given a triangle and we know that the sides are 4, 5, and 6. We're not told anything else about the triangle and we're asked to find all of the angles. So when I look at this, my first thought is I'm pretty sure it's not a right triangle. I know 3, 4, 5s are right triangles. It just doesn't seem like this one's going to fit. So then that leads me to believe that I cannot use just the standard sine, cosine, tangent, trig ratios to find the angles. The other thing that I'm noticing is that my next go-to would be the law of sines. However, I don't have any angle in this triangle, so I don't have an angle and side pair. So if I wanted to look from the 4, I would need this angle here so that I could find any other ones. I would need a pair. I'd need the angle measure and the side. So it doesn't look like I can use the law of sines either. This is when the law of cosines actually becomes important. And the law of cosines is c squared equals a squared plus b squared minus 2ab cosine of c. So this probably looks a lot like the Pythagorean theorem, and you should have realized, if you read the proof, that it actually is coming from the Pythagorean theorem. It's actually used quite a bit. And what I want to point your attention to is, this is a side, and that side happens to be across from that angle. I know that's an angle because it's going into the cosine function. So whatever side I'm looking for, I could use that angle at the end here, or if I was looking for the angle, I would just have to use the side that's across from it there. So that's really kind of an important thing to realize when you're setting it up. So anyway, now that I have this, it doesn't really matter which angle I start with. I'm just going to go ahead and say let's find this one first. So when I go ahead to set this up, I'm going to get 4 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 multiplied by the cosine of c, whatever c is. And then I'm going to go ahead, and by the way, notice it doesn't really matter which one's a and b. It's going to work out the same no matter what. So I'm going to get 16 equals 25 plus 36 minus 2 times 5 is 10, so that's 60 cosine of c. And if I keep simplifying, I get 16 equals, and let's see, that's going to be 61 minus 60 cosine of c. Now, at this point, I want to caution you because every year students have a common mistake of they take 61 minus 60 and they just go ahead and write 1 times the cosine of c. That would be wrong because when you look, that negative 60 actually is actually being multiplied by the cosine of c, or the 60 is being multiplied by the cosine of c. So you can't combine that term. You can't combine this term here with this term here. They're not like terms. Like I said, the second one has multiplied by the cosine of c in it. So I'm not going to do that, which means when I go ahead to go to solve this, I'm going to go ahead and subtract 61 from both sides because I'm trying to solve for c here. And so what I'm going to get is I'm going to get negative, I should keep using orange, negative 45 equals negative 60 cosine of c. And then I'm going to go ahead and divide by the negative 60 there. And I'm going to get 0.75 equals the cosine of c, which instantly makes me think I'm in the first quadrant, because I didn't get a negative value, so it means c is going to be smaller than 90, which makes sense. And then if I do inverse cosine 0.75. We would get C, which is approximately 41.410 degrees. And so that's how I would get angle C in this question. Or sorry, the angle across from the side length of 4. Now at this point, I now know what that orange angle is. I know that it's 41.410 degrees. And, if I need to find the other angles, I now realize that I have an angle side pair. To find that purple angle up there, the angle across from the side of 5, I could go ahead and use the law of cosines again if I chose to, or I could use the law of sines because like I said, I have one of the angles now. Now, me personally, I'd probably use the law of sines. Either way, I think that you get the idea of using the law of cosines here, so I'm just going to list the other 2 angles so that you have them if you wanted to try and make sure that you get it. So the angle across from the side of 5 is 55.771 degrees. And then our angle that's across from side of 6 is going to be 82.819 degrees. Now, like I said, if you wanted to, you could go ahead and use the law of cosines to try to get one of those angles and make sure it matches up. If this was a problem I was doing, I would only use the law of cosines once, and at this point I would be using the law of sines. Hope this helps. Have a great day.